When we look at measures of relative standing, we're looking at ways to compare values in a data set in relation to each other. Okay, there are two very common ways to do this. One of them is quartiles and the other is percentiles. Okay, what quartiles do is divide the data into 4 equal parts or quarters. So if there were 100 data values, that would mean that it divides 25 data values into each quartile. So Q1 is called the first quartile. That contains the bottom 25% of the data values. Q2 is the second quartile. That contains the bottom 50% of the quartiles, which should be the same as the median. And then Q3 is the third quartile, containing the bottom 75% of the data values. Okay, and again, what that means is that if there was 100 data values in your data set, 25 of them would be at Q1 or below. 25 of them would be between Q1 and Q2 for a total of 50% below Q2. And then another 25% will be between Q2 and Q3. So 25 of those 100 data values would be between Q2 and Q3 for a total of 75% at or below Q3. Okay, and if you had a score on a test at Q3, then your score is higher than or equal to 75% of all other scores. It does not mean you received a 75% on the test, nor does it mean you even passed the test. It just means if there were 100 people that took the test, your score was greater than or equal to 75% of all other scores. It doesn't mean you did well on the test or poorly on the test. It just means that your score beat 75% of all other scores. Okay, percentiles are very similar to quartiles, except instead of dividing into 4 equal parts, percentiles divide the data into 100 equal parts. So P sub 10 represents the 10th percentile, which means that 10% of the data lies at or below P10. Okay, P25 is the 25th percentile, and that's the same as Q1, okay, the first quartile. And then P90 is the 90th percentile, okay, meaning 90% of the data lies at or below P90. Okay, so very similar to the quartiles, if your score on a test is at P90, your score is higher than or equal to 90% of all other test scores. It does not mean you got a 90% on the test, and again, it doesn't even mean that you passed the test. Okay, maybe everybody failed the test, but whatever your score was, it beat or tied 90% of all other scores. Okay, so we'll do a quick example. Okay, a fairly basic example. Okay, so suppose you're given a ranked or ordered list of 20 scores on a stats exam. Okay, so 38 is the lowest, and then 47, 59, and so on. Okay, so they're in order. Okay, if you want to find the percentile value of X, okay, meaning whatever data value or test score in this case you're looking at, if you want to find what percentile is that data value at, you take the number of data values that are less than X, divide by the total number of data values, and then multiply it by 100. Okay, and we're going to round to the nearest whole number. So a score of 72 has what percentile value? Okay, basically asking, if you received a 72 on the test, what percent of scores did you beat or tie? Okay, so for a score of 72, you find the number of data values that are less than 72. Well, 72 is right here, and that is higher than 1, 2, 3, 4, 5, 6 of the data values. So you take 6 out of the total number, 20. Okay, so 6 out of 20. Okay, which is 0.30. So a score of 72 is at the 30th percentile. So you say P sub 30 equals 72. So the 30th percentile is 72. Okay, and I just wrote a little sentence on what that means. 30% of the data lies below a grade of 72. Okay, and you can word it a few different ways, but that's a good way to word it. Okay, a score of 83 has what percentile value? Well, you do the same thing as you did on the last one. Okay, and if you need to pause the video, I'm going to show you the answer. Okay, but you can do this. I'm going to show the answer and move on to keep this brief. Okay, you'll see 83. Okay, is right here, which is higher than half the data values, 10 out of the 20. So 10 out of 20 is 50%. So it's the 50th percentile. Okay, now suppose you want to go the other way. Okay, basically go backwards. If you want to find the location, okay, we'll call it L, of a data value of the kth percentile. So now we're given the percentile, like the 80th percentile or 20th percentile. And you want to find what data value would that be? Okay, this is what you would follow. Okay, so there's kind of a checklist you go through, or a step-by-step process you go through. Okay, L equals N, which is the number of data values. In this case, it's 20. K is the percentile that we're looking at. And then you divide by 100. Okay, if you end up getting a whole number, then what you do is you're going to average that number, the Lth value, and the L plus first data values. And this will make more sense when we actually do the example. If you end up with a decimal, so when you do this calculation, n times k over 100, and you get a decimal, you're going to change L, the location, by rounding up to the next whole number. Okay, so if you want to find the value of the 25th percentile, P25, so that's asking you what data value or what test score had 25% of the data values less than it. Okay, so you do n times k over 100. Okay, so 20, okay, the number of data values, 25% is 25 over 100. And that gives you L equals 5. So the first case, L is a whole number because we end up with 5. There's no decimal there. So you get a whole number. So you're going to average the L and L plus first data values. So that's averaging the 5th and 6th data value. So you go up to the list. So here's the 1st, 2nd, 3rd, 4th, 5th data value is 68. And 70 will be the 6th data value. So you average those together, basically add them, divide by 2, or it's fairly easy to tell that 69 will be between those two data values. Okay, so P25, the 25th percentile, is 69. Okay, so if you got a 69 on the exam, that would have been greater than or equal to 25%. Of all other scores. Okay, find the value of P75. Okay, so you can take a minute and pause the video, and I'm going to move on and show the answer, but the process is the same. Okay, doing the n times k over 100, and then following the directions. Okay, so I'll show the answer. Okay, and this one you end up with L equals 15. So you average the 15th and 16th data value, and then the 15th value was 84, the 16th was 89. They averaged 86.5. Okay, and then the last one. Okay, it's a little more awkward here. Find the value of P86. Well, again, you do the n times k over 100. Okay, and when you do that, 20 times 86 over 100, you end up with 17.2. Which is a decimal, so that's when you change L by rounding up to the next whole number. Okay, so we can see that'll be the 18th data value, which is 91. Okay, and what that would be telling you is if somebody scored a 91 on the exam, they beat or tied 86% of all of the test scores. Okay, and then the next thing we look at is something called the IQR. Okay, the interquartile range. Inter meaning between, quartile meaning quarters. So the IQR is found by evaluating Q3 minus Q1. It basically just gives the range of the 50% of the data in the middle, okay, or the middle 50%. Okay, so from the previous example of the exam scores, find the IQR. Well, on the previous page, we found P75, which is Q3, and P25, which is Q1. So that's 86.5 and 69. Okay, so when you do Q3 minus Q1, you do 86.5 minus 69, and you get the IQR equals 17.5. Okay, so basically the range of the middle 50% of the data is 17.5. Okay, the IQR just gives you an idea of how spread out the data are. Okay, where we really use the IQR is to determine if we have an outlier. Okay, what an outlier is, it's an observation or observations that lie outside the overall pattern of the distribution. We call an observation an outlier if it falls more than 1.5 times the IQR below Q1 or 1.5 times the IQR above Q3. Now that'll seem a little confusing just to look at and understand what that means, but we have the IQR 17.5. We're going to multiply that by 1.5. Okay, and then we're going to go below that amount. So we're going to take Q1 and subtract that amount and get another number. And we're going to take 1.5 times the IQR and add it to Q3, so go above Q3 by that amount, and that'll give us another number. Any data value that are more extreme than those two numbers will be considered an outlier. So if we're looking at this data set of the exam scores, okay, we're going to calculate 1.5 times the IQR. Well, that's 1.5 times 17.5. Okay, and when we do that, 1.5 times 17.5 is 26.25. So that's what 1.5 times the IQR is. Now we're going to subtract that from Q1 and add that to Q3. Now one way I like to show the work on this is I label Q1 and Q3. Okay, so 69 and 86.5. And then I take those two answers we get when you do minus 1.5 times the IQR. So if you do 69, subtract 26.25, that'll give you 42.75. So any data value that is more extreme than that, so less than 42.75, we'll say that's an outlier. Okay, so that data value or data values would be falling outside the overall pattern of our distribution. And then on the other side, if you add the 26.25 to Q3, the 86.5, you end up with 112.75. And any data value more extreme or higher than that will also be an outlier. Okay, so when you go back to your data set and look at it, there are no test scores higher than 112.75, but there is a test score less than 42.75. Okay, so we can see in our data set here that a 38 is less than 42.75. So 38 is an outlier because it's more than 1.5 IQR below Q1. Okay, so that's where we really use the IQR to determine if we have an outlier. Okay, the very last question here. So in general, how are the mean, median, mode, standard deviation, and range affected by outliers? Okay, so if you have one or more data values that are outliers, okay, how does that affect all of those measures of central tendency and variation? Okay, now a silly example I give for that is that if you live in a relatively small town and you look at the wealth of people in town, like the net worth of people in town, many people would have net worths of 100,000 or maybe even a little more. Okay, a lot of people, like a lot of students or younger people, they haven't built up a lot of wealth yet. Okay, so their net worth may be like 10 or 20,000. Okay, well, if you have somebody that's really rich move to town, like say Bill Gates or Jeff Bezos, okay, if they move to town, what does that do to these statistics for net worth? Well, the mean, remember, that's the sum of the data values divided by the number of data values. Well, if you get a very large number added to your data set, then that's going to bring the average up. Now, if it's on the other side, though, so just suppose it was just kind of an opposite example, the mean can be pulled down toward the outlier. Okay, so in general, the mean will be pulled toward wherever the outlier is. So if you have a data set that has a bunch of high numbers in it, so just say, for example, you had several students take an exam and they all got in the 90s, and then one other student takes the exam and they get a 10. Well, what the average before in the 90s, now it's going to be pulled down lower toward the 10. Okay, so now without knowing how many data values there are, like the average now for the test may be in the 70s or 80s, but it's going to be pulled toward the 10. Okay, the lower outlier. Okay, now as far as the median goes, well, the median is the middle number, and the median or the middle number generally won't change. Okay, so if you have going back to that Bill Gates example, if you had 20,000 people in town, well, the middle number being right around 10,000, if one more person moves to town, it's not really going to change where that middle number is. Now, technically, it may change it, but it's not going to greatly affect the median. Okay, the mode. Well, an outlier will not change the mode because the idea behind an outlier is you're not going to have more than one be an extreme value, I should say be the same extreme value. Okay, and then as far as the standard deviation and range, remember those measure how spread out the data is. So if you have outliers, that's going to increase both of those. Okay, the standard deviation and the range will go up. It doesn't matter whether the outlier is on the lower end or the higher end. Okay, the standard deviation and the range will go up. Remember, standard deviation is the average distance from the mean. So that average distance will increase whether the outlier is on the low end or the high end. Okay, so that was measures of variation.